Okay, so what I'm going to go through in this video is the pH scale and what we can do to test substances to find out what pH it is. First thing I'm going to show you this scale. Lowest number is 1, highest number is 14. We can see it's a colour scale going from red through to oranges, yellows, greens, blues, and then very dark blue, purple. At the top of the scale we have our strong acids, so pH 1, 2 and 3 are our strong acids. As we go further the scale, pH 4, 5 and 6, they are our weak acids. We then come to neutral in the middle, that's pH of 7 is neutral, and this tends to be the green colour. Moving up we then go to weak alkalis, so pH 8, 9 and 10 are our weak alkalis. Then our strong alkalis are from pH 11 to 14. Okay, so our most reactive substances are our strong acids and our strong alkalis. We've got some examples here, so sulfuric acid, nitric acid and hydrochloric acid, they're our strongest acids, and things like lemon juice and Coca-Cola, they're also quite strong acids as well. This is why things like Coke actually damage your stomach quite a lot. Vinegar, very acidic as well. Tea is actually slightly acidic. Water and our blood is obviously pH 7, very neutral. Toothpaste and milk tend to be weak alkalis, and some of our cleaners like drain cleaners and other things that was like sodium hydroxide and potassium hydroxide, they're very strong alkalis. Now we can test these different substances for their what pH they are, by a variety of ways. Now we can use something called litmus paper, or we can have universal indicator paper. Now these change colour when you use them. So litmus paper, the red paper turns blue if it's an alkali, and the blue paper turns red if you're adding an acid. Now this is quite complicated. Basically there are two different types of litmus paper, a red one and a blue one, and if they change colour then they represent the opposite to whatever they've put in. So this one, for example, they've put a substance in there, the blue paper has turned red, so this means that it's an acid in that substance. But if we look at something like universal indicator, that can be in liquid and paper form as well. If we use the liquid form of universal indicator, we put a couple of drops into any solution, then it changes the colour. What you will notice about this colour scale is it's exactly the same as the pH scale I've just shown you on the other page, and it shows us a direct colour that matches up to the pH of the solution. So we can find that universal indicator is probably more widely used or easier to read, because it gives us a more accurate depiction of whether it's a weak acid, strong acid, etc.